Hello everyone and welcome to a new episode of All Things IDA. This is a two-part video. The first video we're gonna be covering today is in also GDL.hpp. We're gonna talk about flowcharts and how to generate them, how to generate dot files, for example, function call graphs, actual graph view like of a function and so on. In today's video, we're gonna cover just the beginning introductory functions. And in the next part, we're gonna cover the QFlowChart class, which is much more interesting. All right, let's get started. As usual, I refer to the SDK file. In particular, we're gonna be looking at gdl.hpp file. And that's the file where we have the flowchart functionalities. So we have something called block type, for example. Is it a normal block, indirect jump, return, external block, extern? We'll see how that manifests basically. So let's continue to some other helpers. We have a supporting class, integer set, just a set of integers. And these will be block identifiers. So when we ask IDA to compute the flowchart of a range or a function, um, behind the scenes as well, it assigns unique block IDs as well, in additional to the range information associated with that block ID. But programmatically, we'll be using the block ID to query the flowchart. So we don't have to focus on that right now. And let's just quickly go over the GDL graph. So this is the base class that we'll be indirectly working with. Just to give you an idea of the functionalities, once we compute the flowchart for a function or range, we can ask for the size. So this will give us how many nodes, but the size is just how many nodes, and then we can ask for an entry node, exit node. Of course, we might have multiple exit nodes. Then we can query about how many successors a given node ID. So that's where the node ID comes into play. How many predecessors for a node. And then we can ask, okay, now give me the successor for a given node, successor number I. So if we combine the successor quantity and retrieving successors, basically, so for every given node and the number of successors, we can retrieve the successor node ID. And that's how we can have all the connections between every single node. Same for predecessors. Generate GDL file, we'll talk about that, and separate functions basically, which basically leads directly to the topic. Let's get back to this in a second and explore generate flowchart. So this is a very high level function. It just generates a flow graph and directly goes to a file. Now this is useful and not useful in the sense that we can generate it directly to a file, but we cannot programmatically reason about it. But let's try it out. So generate flowchart. We can start. Let me go to the function main here and gen flow graph. And all right, so let's assign a file name. Let's call it x.gdl. And all right, so the file name, the title is gonna be something, any title we wish. This will go into the file as a if it's applicable. So let's just put some title. Function. We can pass either a function or a range, basically start and end EA. So for now, just for simplicity, let's get the function. So let's get IDC, IDAPI dot get function at IDC dot here. and we're not gonna pass any range, but we're gonna specify some of the graph flags. So we can generate a dot file, we can test it out, and we can generate a GDL graph. And also we can specify to directly display the graph. But we're gonna do this in two steps just to illustrate this API. So let's ask it to use GenGDL, short GenGDL for now, and let's say okay. And if okay, for now let's just say success. Okay, so if I run it, I get success. If I display the file ctemp.x.gdl, so this is the GDL file. Here we got the title we specified, and so on, some configuration, and then the contents, which will look very similar to the actual graph view in IDA. But graph view is basically before GraphView existed, IDA was using WinGraph. So now that we have GenGDL, we can pass an additional flag to directly display it, or we can also display it on the side. But be careful, this function, per the documentation, it expects that the file name we pass is temporary, and so it will be deleted once it's displayed. So that file will go once we display. So display GDL, the same file name I passed, I created, and if we were successful, we should be able to display it, and the file will be deleted. So this file right now still exists, and any second it won't. So here we go. We have the graph WinGraph tool from IDA that ships with IDA basically. We have the title of our graph, some title, and this is the flowchart of the function. Here this function has multiple return points, and that's nice, as we will see, for example, in an example next, what we can do with this. All right. Let's quickly test if we pass a dot flag, so we generate a dot file instead of a GDL file. So we're gonna rename it here x.dot. I'm gonna delete the existing one I have. So now let's try. So we do have x.dot. Now I'm going to dot minus t png minus o x.png x.dot. And now we created, we visualized the dot file. And here we go. This is just an image that we get IDA to generate for us. We have generated simple call chart. This is gonna be for the whole program, basically, just the call relationship. We can test it. So let's call this one here, this, and this one. All right. So we don't have to specify any range or function. It's gonna do for the whole thing. So let's say this, same story. Let's just let's do the same except just the function call. Okay, so simple call, file name, wait. So if this is, because this is gonna compute for the whole database, it can take some time. So we can, IDA might show us a wait dialog. So file name, waiting title, the title of the generated call chart, and we don't have to specify a function or or a range, and let's keep using GDL and GDL. All right, let's see. So here, for example, this is our start, and other functions individually and so on. And since this is one graph, we can change the layout and so on. Again, this was the precursor to the built-in graph viewer and IDA. So I think this is since like IDA 4.0, the first time IDA became a graphical user interface. Then we have the complex call charts and also the actual programmable Q flow chart. Thank you, and if you like this video, please subscribe and like.